Computer network topology is how various network components like nodes and links are arranged. It defines the network's layout, or structure, both physically and logically, determining how systems connect and communicate. Topology can be physical or logical. Physical topology is the actual layout of network nodes and cables, showing how they are physically interconnected. Logical topology, on the other hand, describes how information flows between different components. There are several types of physical network topologies, including bus, star, ring, mesh, tree, and hybrid. In bus topology, all devices connect to a single, shared cable or bus, which acts as the common communication media. Terminators at the ends of the bus are used to absorb signals. Advantages of the bus topology include ease of installation, low cost, and simple extension. However, performance decreases with more devices, signals can be weak, and troubleshooting is difficult. Star topology connects every node directly to a central device, which is typically a hub, switch, or router. This central device manages data flow and is common in modern local area networks, or LANs. The central device can be a basic hub, which forwards data to all nodes, or an active hub that also regenerates signals. A more intelligent switch directs data only to the intended recipient. A router manages data between different networks. Star topology offers easy management, scalability, and centralized control, making troubleshooting simpler. It relies on dedicated cables for each connection, supporting network reliability and allowing multiple cable types. The central hub allows for straightforward monitoring and control of network traffic. Network administrators can easily identify, isolate, and resolve issues, ensuring minimal disruption to the overall network. Scalability. Star topology enables seamless expansion of the network. Adding new devices simply involves connecting them to the central hub with a dedicated cable, making it ideal for growing organizations or environments where device count may frequently change. Multiple connections. Each device in the LAN has its own point-to-point connection to the hub. This setup reduces the likelihood of data collisions and maintains consistent performance, even as more devices are added. Centralized control. The hub acts as the main controller of data transmission within the LAN, efficiently directing traffic and minimizing bottlenecks. Impact of damage-prone cables. While the need for individual cables increases installation complexity and cost, it also means that a failure in one cable typically affects only the connected device, not the entire network. However, in environments with many physical obstructions, cables may be prone to damage, so protective measures are recommended. Disadvantages of the star topology are that the entire network fails if the central device malfunctions. It also requires more cabling and may need a device to rebroadcast signals. This image shows the structure of a ring topology. In ring topology, each device connects to exactly two others, forming a circle. Messages flow in one direction, often using a token passing system. This system ensures orderly transmission by allowing a device to send information only when it possesses the token. Ring topology offers an orderly network where every device gets access to transmit and performs well under heavy loads. However, the failure of one computer can affect the entire network. Troubleshooting is difficult, and changes affect the whole network. Mesh topology connects every device to every other device with separate cables, offering high reliability through redundant connections. Messages are sent directly from the sender to the receiver. Mesh topology's advantages include enhanced error tolerance due to redundant links and ease of troubleshooting. The main disadvantages are that it is difficult to install and maintain, and it is expensive. This diagram illustrates the network structure of a tree topology, with a parent node at the top and branching levels below. Tree topology features a central root node connected to nodes at lower levels in a hierarchy, using point-to-point links. The structure is symmetrical, with each node having a specific fixed number of nodes connected to it at the next lower level. Tree topology is scalable and manageable, simplifying fault identification. Its disadvantages include potential maintenance issues over large areas. Since it's a variation of bus topology, failure of the backbone cripples the entire network. Hybrid topology combines two or more basic topologies, such as star ring or star bus networks, to create a network that does not conform to a single standard topology. Reliability and fault tolerance. Because it combines multiple subnetworks, a failure in one section typically does not bring down the entire system. Faults are easier to isolate and troubleshoot without affecting the rest of the network. Scalability. It is highly expandable. Flexibility and customization. Organizations can tailor the network to their specific requirements by maximizing the strengths of different topologies. handling high-traffic hybrid networks are designed to manage large volumes of data and are particularly effective in wide-area networks, WAN networks. Disadvantages includes complex design, high implementation cost, maintenance challenges, hardware requirements.